In class, we've been talking about functions and what they mean. We've defined functions. We looked at how a function can be both a relationship between two numbers, but it can also be a relationship between two items, like a name and immersion trip. We've also looked at functions, trying to determine if the input-output, any given input-output variables satisfy a function. And we looked at some word problems where we write an equation and find the solutions. Now, we're going to take those same ideas and apply it to the same situation, just written a little differently. So that's where this word notation comes in. Notation really just means how are you noting? How are you noting the information? Right? So you might... Okay, so when we're looking at functions, we might see something that's written like this. We might see g colon x arrow 4 plus 3 x minus x squared. Okay, so this is kind of a little bit, it looks way more complicated than it actually is. So remember when we were talking in class that mathematicians usually use the word such that kind of defines a rule, right? So I think the example that we used was dress code on Fridays such that everyone must wear a collared shirt, right? So specification within this other general rule. Okay, so here what we have is this g is the name of the function. Okay, so we're saying g such that, remember colon means such that, x is the input variable, or is the name of the domain, right? It's the set of x's. So we've got g such that x is, and then this arrow just means is, okay? What I like to do is rewrite this so it makes just a little bit more sense. So I'm going to say the name g is defined by x. And then the arrow is going to turn into an equal sign, and then the rest of it just stays the same. Okay, so now what I've got is this thing right here. I'm not sure what that means yet, but I definitely understand what equals 4 plus 3x minus x squared. This I feel more comfortable with than that there. Okay, so now this here, I still have the name of the function, and then in parentheses, I still have what the input value is. So how I read this is g of x. G of x is, or g of x equals 4 plus 3x minus x squared. Okay? G of x is the same thing as y. So I could write this whole thing, this is what we're used to seeing, y equals 4 plus 3x minus x squared. Okay? Right here, this equation is probably what we're most comfortable with. This notation here is what we call function notation. And it gives us both the name of the function and the name of the variable that we're plugging in as the input value over here. This is called arrow notation, and it gives us the same information that function notation does. What I encourage you to do when you look at your homework is change from arrow notation to function notation, and then use an input-output chart in order to figure out the domain and range. Okay, so domain and range. Remember that domain is the set of all of our input values, and the range is the set of all of the output values. So let's look at an example that uses all of this information. All right, so here is an example problem. It says list the range of g of x equals x plus 3x minus x squared, given that the domain is these values, -1, 0, 1, and 2. Okay, so the first thing that I'm going to do is I'm going to rewrite this part of the notation into function notation. So it's going to look like g of x equals 4 plus 3x minus x squared. Okay? Then I'm going to make an input-output table. I'm going to have my values of x, and my output then is g of x. Okay? And then this work in the middle is just where I'm recording the plug-in process. Okay, so now the values that I got for the domain, I'll list on the side here. And I'll plug each one of these numbers into the equation there and get the output values. So from here, you should be comfortable. This is what we've been doing for many, many different sections in the year, just looking at this in lots of different iterations, different ways of looking at this. Right now, though, the only thing that's changed is the notation and the way that all of this is worded. So we're given a domain, we're looking for a range. Given an input, we're looking for an output. Okay, so I did the plug-in process, and I noticed that I've got, I've got 4 minus 3 minus 1. 4 minus 3 is 1 minus 1 is 0. And then I've got 4 plus 0 minus 0 is 4. And then I've got 4 plus 3 minus 1 is 6. And then I've got 4 plus 6 minus 4 is also 6. So now what I'm going to do is I've got all 4 of my output values, and I'm going to write my range. I'm going to say range equals, then put it in set notation, which is that curly bracket. I'm going to list all these numbers. So I've got a 0, 4, and a 6. Now the 6 is listed twice, but I don't have to list it twice in my domain, because I'm just saying, like, this is when we were matching the name and the immersion trip. Even though the immersion trip happened, multiple people went on the same immersion trip, we still only listed New Orleans one time in the list, right? So these numbers are the answers, or the output values, but I only list each of those numbers once. So my solution to this problem is that. That's the range. So now what I would like you to do is work the problems that are listed on my essay. They're off of page 380, and we're looking at 1 through 15 odd. And just follow this pattern. Simple substitution, a little bit of number crunching, and the biggest thing is recognizing this new notation.